and listen to this video and place ourselves in the presence of the Lord.
Diyos na banal, maraming salamat po sa pagkakataong ibinigay ninyo sa aming lahat upang makapag-aral. Salamat po sa pagbibigay ninyo sa amin ng isang guro na matiyagang hinuhubog ang aming isipan sa araw-araw. Salamat din po sa aming mga magulang sa patuloy na pagkakaloob sa amin ng aming mga pangangailangan. Gabayan naman po ninyo kami upang makita ng aming mga mata ang mga aral na ibinibigay ng aming tagapagturo. Bigyan niyo po kami ng talas ng isip upang matalos sa mga bagay na kailangan naming malaman. At numbayan mo po kami sa aming mga landas na piniling lakarin. Wala po kaming magagawa kung walang inyong tulong at mga pagpapala. Gabayan din naman ninyo ang aming guro upang maibigay niya ng lubusan ang mga paliwanag na aming kakalanganin sa pagharap sa kinabukasan. Bigyan din naman ninyo siya ng matiyagang kalooban upang mapatawad ang aming pagkukulang. Sa harap ninyo at sa inyong bugtong na anak, inaalay namin ang araw na ito. Amen.
Okay, good morning once again. Before we shall start our virtual classroom presentation, I want you to be aware of the following rules. First one is for you to be prepared. Arrive on time, dress, and have your materials at hand. Second, be attentive. Show that you understand with the hand nod, hand gestures, or thumbs up, or feedback icons. Third is to be active. Take notes, use chat, or raise your hand to share questions or ideas. And number four, be polite. Mute mic unless called on. Turn camera off or use a background if you are in a distracting space. Okay, so last week, I gave you a task to accomplish for 3 days. We call this activity as web-enhanced learning activities. Okay? This activity that I gave you last week is focused on volume-temperature relationship, or called Charles' law. The objective of this activity is for you to investigate the volume-temperature relationship. Now, before presenting your finished output through PowerPoint presentation, let me explain the parts of the said activity. The first part of the activity is called the introduction. This part establishes the context of your activity. So this focuses mainly about the topic Charles' law. The second part of your activity, the task. This serves as your mission. Your mission here in your activity is for you to demonstrate understanding how gases behave based on the motion and relative distances between gas particles. Specifically, you will investigate the relationship between volume and temperature at constant pressure. So you are given 3 days to finish the task. Once you've gathered your data, present your output through virtual presentation. The third part of your activity that I gave you is the process. So what is this process all about? It consists of the resources, website link or URL, or uniform resource locator for you to be able to accomplish the given task. So I gave 5 URLs I already evaluated all of this, and I'm pretty sure that all of the articles are reliable and very easy to understand. Next part is called the question. I gave 5 questions that you need to answer. The answers are found in the given resources that I gave, in the given URLs that I gave. The number one rule that I gave was do not copy paste the answer in the given web resources or web links. That is why you really need to read and comprehend the articles found in the given resources. The next part is called the evaluation. I already explained this to you last week. The rubrics consist of 5 skills. The first one is called contribution or attitude. Second, cooperation with others. Third, focus or commitment. Fourth, ability to communicate. And the last one is called correctness. So the highest possible score here that I can give you is equal to 20 points. And the lowest point that I can give is 5 points. The last one is called the conclusion. So you need to state and explain Charles' law based from kinetic molecular theory. I'll be the one to present your PowerPoint presentation since you already uploaded it to me. So are you ready? Let us start first with group 1 and then 2, 3, 4, and 5. Okay, you are given 4 minutes to present your output. Okay, let's start first with group 1.
Good morning to everyone. Thanks especially to our science advisor, Mr. Marlon Lag, and it is such a pleasure to join with us our new principal, Mr. Edward Garcia and Sir Gary. Stay put and I will start the presentation of Group 1, Charles' Law. The first question. Based from Charles' Law animation, describe the relationship of volume and temperature. What happens to the volume of gas when temperature increases? Based from the kinetic molecular theory, as the absolute temperature increases, the volume of the gas also increases in proportion. In other words, at constant pressure, volume of gas is directly proportional to its absolute temperature. Second, describe the graph between volume and temperature. As I said a while ago, the graph shows that the absolute temperature is directly proportional to the volume of gas, which makes a straight line in the graph. Third one, states Charles' law and write its mathematical equation. Charles' law is a special case of the ideal gas law. It states that the volume of a fixed mass of a gas is directly proportional to its temperature. The Charles law is expressed as initial volume over initial absolute temperature is equal to final volume over final absolute temperature. In solving the problem, we shall use the mathematical equation of Charles' law. A sample of hydrogen has an initial temperature of 50 degrees Celsius. When the temperature is lowered to 10 degrees Celsius, the volume of hydrogen becomes 2 liters. What was the initial volume of the hydrogen? Given, initial absolute temperature is equal to 50 degrees Celsius. We should convert it to Kelvin, 323 Kelvin. Final absolute temperature is equal to 10 degrees Celsius, convert to Kelvin, 283 Kelvin. Final volume is equal to 2 liters. Find out for the initial volume. Solution. We will use the formula initial volume is equal to final volume multiplied by initial absolute temperature over the final absolute temperature. So now we will substitute it. Initial volume is equal to 2 liters times 323 Kelvin over 283 Kelvin is equal to 646 liters divided by 283. Our initial volume is equal to 2.28 liters. Give the real-life application of Charles' law. Pool floats. Pool floats are filled with air that makes them less dense than water. When water is cooler than air, the air in swim floats shrinks because of a decrease in temperature of the air inside floats. The reverse phenomenon is observed during hot summer days when water is much warmer. In a hot climate, the temperature of the air inside a pool float increases and they get overinflated. We therefore conclude that Charles' law states that the volume of a fixed mass of a gas is directly proportional to the temperature. This law applies to ideal gases held at a constant pressure, where only the volume and temperature are allowed to change. Volume is directly proportional to its temperature if pressure is constant. Thank you and stay safe.
Okay, very good Group 1, very good Rachel Roldan. Now, based from your presentation, Rachel, or Group 1, what is the relationship then between volume and temperature?
The relationship of volume and temperature. The volume is directly proportional to its temperature in constant pressure.
Your initial temperature is 323 Kelvin and then 283 Kelvin. So what happens to the temperature based from the problem that you presented?
The temperature decreases from 323 Kelvin to 283 Kelvin, sir.
Okay, very good.
Temperature.
So according to Charles' law, when temperature decreases, volume also decreases. Very good, Group 1. So let's give Group 1 a big hand, please. Okay, very good. Okay, let's proceed now to the output of Group 2. Who will present the output of Group 2?
Zyrine, sir. Good morning, everyone. This is the presentation of Group 2, Charles' Law. The first question. Based from the Charles' Law animation, describe the relationship of volume and temperature. What happens to the volume of gas when temperature increases? Our answer is, as the volume is directly proportional to absolute temperature, which means when temperature increases, volume of gas particles also increases or vice versa. Next question. Describe the graph between the volume and temperature. Our answer for this question, the graph between volume and temperature is a straight line graph which indicates a direct proportion relationship. The next question. State Charles' law and write its mathematical equation. Our answer is Charles' law states that the volume of a certain amount of gas held at a constant pressure is directly proportional to its absolute temperature, wherein volume is directly proportional to temperature. Volume is equal to constant variable multiplied by temperature, or constant variable is equal to volume divided by temperature. Charles' law mathematical equation. Initial volume all over initial temperature is equal to final volume all over final temperature. We shall use the mathematical equation of Charles' law in solving the problem. 284 milliliters of chlorine at 298 Kelvin will occupy what volume at 248 Kelvin while the pressure remains constant? What is the final volume of gas? Given, initial volume is equal to 284 milliliters. Initial temperature is equal to 248 Kelvin. Final volume is unknown. Final temperature is equal to 298 Kelvin. The formula that we use is final volume is equal to initial volume multiplied by final temperature all over initial temperature. So we substitute the given. Final volume is equal to 284 milliliters multiplied by 298 Kelvin divided by 248 Kelvin. 284 milliliters times 298 Kelvin is equal to 84,632 milliliters divided by 248. The Kelvin is removed because we cancelled it. 84,632 milliliters divided by 248 is equal to 341.26 Kelvin. So as we can see, the final temperature increases based from the given. So because of volume temperature relationship, the final volume will increases too. Real-life application of Charles' law. A common problem with ping pong balls is they can get a dent when exposed to a strong blow or pressure. A common method to fix this dented ball is to immerse the ball into warm water. On immersion, the temperature of the air inside the ball increases, and as per Charles' law, the air expands. The ball is inflated and dents are fixed. To sum up all informations, Charles' law. The volume of gas is directly proportional to absolute temperature at constant pressure. Volume is directly proportional to absolute temperature when the pressure is constant. Constant variable is equal to volume all over temperature. Charles' law mathematical equation is initial volume all over initial temperature is equal to final volume all over final temperature. Thank you for listening and stay at home.
Okay. Thank you very much, Group 2, especially to Zyrene. Okay, Group 2. Based from your presentation and based from your output, when temperature increases, Zyrene, what happens to its kinetic energy?
When absolute temperature increases, the relationship between temperature and kinetic energy is directly proportional.
Meaning to say, when temperature increases, the kinetic energy of gas particles also increases. And therefore, its volume increases. Okay, very good. Give them a big hand, please. Very good, Group 2, I should say. Okay, let's proceed now to the next group.
Good morning, everyone. This is the presentation of Group 3. First question. Based from the Charles law animation, describe the relationship of volume and temperature. What happens to the volume of gas when temperature increases? Based from the kinetic molecular theory, when the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be in direct proportion. When temperature increases, volume of gas particles also increases. Second question. Describe the graph between volume and temperature. The graph represents a direct proportion relationship between volume and temperature. Next, states Charles' law and write its mathematical equation. Charles' law states that when the pressure on a sample of a dry gas is held constant, the Kelvin temperature and the volume will be in direct proportion. This relationship of direct proportion can be written as volume is directly proportional to temperature. So this means volume is equal to constant variable times temperature, where V is the volume of the gas and T is the temperature of the gas, measured in kelvins, and K is a non-zero constant. For comparing the same substance under two different sets of conditions, the law can be written as initial volume all over initial absolute temperature is equal to final volume all over final absolute temperature. We shall use the mathematical equation for Charles' law in problem solving. A neon gas at 760 mm mercury has a volume of 12 liters and a temperature of 44 degrees Celsius. Find the new volume of the gas after the temperature has been increased to 85 degrees Celsius at 760 mm mercury. Our solution. Since the temperatures are given in degrees Celsius, you must first change them into Kelvin. Initial temperature is equal to 44 degrees Celsius plus 273 converted to Kelvin is 370. final absolute temperature is equal to 85 degrees Celsius plus 273 when we convert to Kelvin is equal to 358. Initial condition. Initial absolute temperature is equal to 317 Kelvin and our initial volume is equal to 12 liters. Final condition. Final absolute temperature is equal to 358 Kelvin and our final volume is unknown. Change. As we can see, when the temperature increases, volume must also increase. Solution. Initial volume all over initial temperature is equal to final volume all over final temperature. Initial volume times temperature is equal to final volume initial temperature. So our final volume is equal to initial volume times final temperature or all over initial temperature. Our final volume is equal to initial volume times final temperature all over initial temperature. We will substitute the given 12 liters times 358 all over 317. Let's cancel the Kelvin, so our final volume is equal to 13.55 liters. The final volume of 13.6 liters is larger compared to the initial volume of 12 liters as the temperature increases. Give real-life applications of Charles' law. A direct application of Charles' law can be seen in such equipment as an incubator. When air comes into contact with the heating element, it expands and becomes lighter. This lighter air rises, causing the circulation of warm air throughout the incubator. Conclusion: to sum up all information, the volume of gas is directly proportional to absolute temperature at constant pressure, where volume is directly proportional to temperature if P is constant, to volume all over temperature. Initial volume all over initial temperature is equal to final volume all over final absolute temperature. Thank you and stay safe, everyone.
For your information, with the students, an incubator is actually an insulated enclosure in which temperature, humidity, and other environmental conditions can be regulated at levels optimal for growth, hatching, or reproduction. Actually, there are three principal kinds of incubators. We have poultry incubators, infant incubators, the one that you presented, and bacteriological incubators. Okay? The infant incubators are used to provide a warm environmental for babies born prematurely or for infants who are unable to maintain a normal body temperature. Okay? Very good, group 3. Anyway, you're right when you said volume is directly proportional to its absolute temperature if pressure and number of moles are constant. Okay, let's give a big hand to group 3. So let's proceed now to group 4.
Good morning, everyone.
Okay?
This is the presentation of Group 4, the Charles Law. First question. Based from the Charles Law animation, describe the relationship of volume and temperature. What happens to the volume of gas when temperature increases? Based from the kinetic molecular theory, at constant pressure, the volume of gas is directly proportional to absolute temperature. Meaning, when temperature increases, volume of gas particles also increases. Second question, describe the graph between volume and temperature. The graph shows a direct proportion relationship between volume and temperature at constant pressure and number of moles. You can see in the graph that volume and temperature are both increasing. States Charles' law and writes its mathematical equation. Charles' law states that when the pressure on a sample of dry gas is held constant, The Kelvin temperature and the volume will be in direct proportion. This relationship of direct proportion can be written as V is proportional to T. So this means V is equal to KT or K is equal to V all over T, where V is the volume of the gas, T is the temperature of the gas measured in Kelvin, and K is a non-zero constant. The mathematical equation of Charles' law is initial volume all over initial temperature is equal to final volume all over final temperature. We shall use this equation in solving problem involving volume-temperature relationship if the pressure is held constant. Imagine that a gas occupies a volume of 2.0 liters at a temperature of 27 degrees Celsius. To what temperature in Kelvin scale must the gas be cooled to reduce its volume to 1.5 liters if the pressure is held constant? The unknown here is the final temperature. Solution. Remember that temperature should be in Kelvin. Since the temperatures are given in degrees Celsius, you must first change them into Kelvin. Initial temperature is equal to 27 degrees Celsius plus 273 is equal to 300 Kelvin. As you can see from the table, the volume decreases from 2.0 liters to 1.5 liters. Since volume and temperature is directly proportional, if the volume decreases, the temperature must decrease. The formula is final temperature is equal to final volume times initial temperature all over initial volume. Now we substitute the following. From final volume to 1.5 liters, initial temperature to 300 Kelvin, and initial volume to 2.0 liters. And then we multiply 1.5 liters to 300 Kelvin divided by 2.0 liters. Cancel the liters and then we get 225 Kelvin. Therefore, the temperature decreases from 300 Kelvin to 225 Kelvin. A real-life application of Charles' law is tires. Tires of untouched vehicles get deflated during cold season days while get inflated in hot summer days. This unusual behavior is because of Charles' law. In cold season, due to low temperatures, the air inside the tire gets cooler and they shrink, while in hot days, the air expands with temperature. Conclusion. Charles' law. At constant pressure, the volume of gas is directly proportional to absolute temperature. V is proportional to T if P is constant. Constant variable is equal to volume all over temperature. Again, the mathematical equation of Charles' law is initial volume all over initial temperature is equal to final volume all over final temperature. That's end our presentation. Thank you for watching and stay safe, everyone.
Okay, thank you very much, Group 4, especially Mark Gusman. Going back to your application, Mark, this is my question. Why are there more tires blown out on the superhighway in April than December?
Sir, because in April, the temperature is higher than December.
Very good, correct. It means it builds up greater pressure when temperature is very high. The pressure inside the tire is not constant. Okay? Since the pressure increases with temperature, the tire cannot withstand the pressure inside it. The tendency is that it will explode. Okay, very good, Mark, especially group 3. The last group, group 5.
Good morning, everyone. This is the presentation of Group 5. Based from the Charles law animation, describe the relationship of volume and temperature. What happens to the volume of gas when temperature increases? Answer. The volume of gas is directly proportional to absolute temperature. Therefore, when temperature increases, volume of gaseous particles also increases. Describe the graph between volume and temperature. As the volume increases, temperature also increases. The graph indicates a directly proportional relationship between volume and temperature. States Charles' law and write its mathematical equation. Charles' law states that when the pressure of a dry gas is held constant, the volume of the volume is directly proportional to the absolute temperature, where volume is directly proportional to temperature. The mathematical equation is volume is equal to constant variable times absolute temperature, or constant variable is equal to volume divided by absolute temperature, where initial volume is where initial volume over initial temperature is equal to final volume all over final temperature. We shall use the mathematical equation for Charles' law in problem solving. Example: imagine that you are skiing on a beautiful, clear day with a temperature outside of -3 degrees Celsius. The cold air that you breathe is warmed to a body temperature of 3.7 degrees Celsius as it travels to your lungs. In, if you inhale 425 milliliters of air at -3 degrees Celsius, what volume does it occupy in your lungs? Assume that the pressure is constant. The initial condition is the initial condition. Initial temperature is equal to -3 degrees Celsius plus 273 is equal to 270 Kelvin. The initial volume is 425 milliliters. Final condition. The final temperature is 37 degrees Celsius plus 273 is equal to 310 Kelvin, where the final volume is unknown. The table shows that the temperature increases from 270 Kelvin to 300 Kelvin so that volume must increase. The mathematical equation in this problem is final volume is equal to initial volume multiplied by final temperature divided by initial temperature, where the given is final volume is equal to 425 milliliters times 310 Kelvin divided by 270 Kelvin. It is equivalent to 487.96 milliliters. The volume increases from 425 milliliters to 487.96 milliliters because when temperature increases, the volume also increases. Give real-life applications of Charles' law. The most common symptom of COVID-19 virus is fever or high temperature. According to Charles' law, the volume is directly proportional to the temperature. Hence, the volume of the air increases with the temperature. The lungs expands. Conclusion: Charles' law. At constant pressure, the volume of gas is directly proportional than absolute temperature, where volume is directly proportional to temperature if pressure is constant. Constant variable is equal to volume divided by temperature. The mathematical equation is initial volume over initial temperature is equal to final volume over final temperature. Thank you for listening. Be safe.
Okay, very good, Guru 5. I also like your application, no? All about volume temperature relationship, what happens to your lungs when your body temperature increases. COVID-19 plus is a respiratory disease. As the infection travels to your respiratory tract, dear students, of course, our immune system fights back. Your lungs and airways swell and become inflamed. This can start one part of your lungs and spread. That is why I should say, you need to be vaccinated. You tell that to your parents in order to protect yourself and to protect your family, because COVID-19 vaccination is a safer way to help build protection. So this time, I would like also to present same topics that I gave you using an animation. Okay, let's start to pump air particles. Okay, one. As I've said a while ago, the pressure is constant. Okay. The pressure inside a closed circuit is 7 atmosphere. How about the initial temperature? Here, 300 Kelvin. And the initial width, okay, is equivalent to 10 nanometers. We shall use width instead of volume. Just for us to see the relationship between temperature and the width or the volume. Okay, according to kinetic molecular theory, the gas particles are so small in relation to the distance between them that their individual volumes can be assumed to be significant. So the large relative distance between the gas particles means that there is considerable empty space between the gas particles. This assumption thus explains the important property of gas compressibility. So I already explained to you about the kinetic molecular theory anyway. Okay? This time I'm going to increase the temperature by pressing this button upward. You observe the change in temperature, the width of the closed container, and the pressure. Or what is now the final temperature? What is our final temperature?
362.
Okay, very good. 362 Kelvin. How about the width of the closed container?
12.1 nanometers,
What
sir.
is the okay, 12.1 nanometers. Therefore, as temperature increases, the width also increases, or the volume increases. The pressure is constant. Observe the kinetic energy of gas particles when temperature increases. Okay, anyone?
Sir, kinetic energy increases, sir.
As I've said, as the temperature increases, the molecules move faster. If the volume is fixed class, the molecules would be colliding more times with a unit area of the wall. This would increase the gas pressure, the same number of collisions per unit area of the wall per unit time. To maintain the pressure constant when temperature is increased, the volume of the gas has to increase. When the volume increases, the distance traveled by a gas particles before it hits again a particular area of the wall is increased. Thus, the increased number of collisions is distributed over a large surface area of a closed circuit. The number of collision per unit area per unit time is maintained or is constant. Can you follow? That is all about Charles' law in relation to the kinetic molecular theory of gas. Okay, I would like to congratulate groups 1 to 5 kasi lahat ng presentation nyo are all correct. When you said that volume is directly proportional to absolute temperature at constant pressure, that is correct. All the applications of Charles' law that you presented, okay, are all correct. Now, for you to understand well the principle formulated by Jacques Charles, I like to play this video. I created this video. Actually, I already uploaded this one a while ago in my YouTube channel.
Hi, good day. Let us learn about Charles' law. In this video, you will investigate the relationship between volume and temperature at constant pressure of a gas. Do you know why hot air balloon floats? In order to make a hot air balloon rise, heat is added to the air inside the balloon. Adding heat causes the molecules to move farther away from each other. In everyday language, we would say that the air inside expands. When this happens, the total density of the balloon and the air inside it decreases. When the density of the balloon decreases to be less than the density of the outside air, the balloon rises. Well, this is Charles' law in operation. In 1787, the French physicist and balloonist Jacques Charles investigated the quantitative effect of temperature on the volume of a gas at constant pressure. In every experiment, he observed an increase in the volume of a gas with an increase in temperature, and a decrease in volume with a decrease in temperature. In practice, the temperature-volume relationship for any gas can be measured only over a limited range because at low temperatures, gases condense to form liquids. From his quantitative studies, Charles observed that at constant pressure, the graph of gas volume versus temperature yields a straight line. The figure shows a graph for 3 different gas samples in balloons. In addition to the straight lines, another important feature emerged. The lines extended or extrapolated to zero volume, or V is equal to 0. All intersect the temperature axis at the same point, negative 273.15 degrees Celsius. William Thomson, also known as Lord Kelvin, realized the significance of this temperature value. He identified this value as absolute zero, the lowest possible temperature. It is the temperature at which the average kinetic energy of gas particles would theoretically be zero. This was the basis for the absolute temperature scale established by Kelvin in 1848. This scale is now called the Kelvin temperature scale. On the Kelvin temperature scale, 0 Kelvin corresponds to negative 273.15 degrees Celsius. Absolute zero expressed in degrees Celsius is rounded to negative 273. Charles' law states that the volume of a fixed amount of gas is directly proportional to its Kelvin temperature if the pressure is kept constant. In a direct relationship, such as this one, the ratio of the two quantities that change is a constant. To determine whether the volume of gas is affected by temperature or vice versa at constant pressure, two balloons are submerged in water at different temperatures. Hot water has high temperature than cold water. Hence, it is expected that the balloon soaked in hot water will be the biggest and the one soaked in cold water will be the smallest. This is known as the Charles law. He explained that as the temperature increases, the volume also increases. Once the air inside the balloon is heated, its molecules will become more excited, which can cause an increase in their kinetic energy. The amount of kinetic energy that they possess becomes great enough to enable them to push the walls of the balloon. This phenomenon results to an increase in the spaces in between molecules of gases. Hence, the balloon becomes bigger. Mathematically, Charles' law can be expressed as V is directly proportional to T at constant P, where V is the volume and T is the temperature expressed in Kelvin. Removing the proportionality symbol and using the equality sign, the equation will be as follows. V is equal to K times T, or K is equal to V divided by T. Thus, in the direct proportion, the quotient of the variable is constant. If you are going to consider the initial and final conditions, you will arrive at the following equations. V1 over T1 is equal to K, and V2 over T2 is equal to K, whereas V1 is the initial volume and V2 is the final volume. T is the initial temperature and T is the final temperature. If the volume temperature ratios are the same in the initial and final conditions, then we will arrive at this equation. V1 over T1 is equal to V2 over T2. Let us apply Charles' law in solving problems related to volume-temperature relationship in gases. A balloon inflated in a room at 24 degrees Celsius has a volume of 4 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What is the new volume if the pressure remains constant? In solving this problem, let us use the ACE method. ACE stands for Analyze, Calculate, and Evaluate. First, we need to analyze the problem. List down the knowns and the unknown. The knowns are V1 is equal to 4 liters, T1 is equal to 24 degrees Celsius, T2 is equal to 58 degrees Celsius. The unknown is V2. Use the known values in Charles' law. V1 over T1 is equal to V2 over T2 to calculate the unknown value, or the V2. The next step is to calculate, or to solve for the unknown. Because the gas law will be applied, express the temperatures in kelvins. So we have T1 is equal to 24 degrees Celsius plus 273. The answer is 297 Kelvin. T2 is equal to 58 degrees Celsius plus 273. The answer is 331 Kelvin. Rearrange the expression for Charles' law to isolate V2. V2 now is equal to V1 times T2 all over T1. Substitute the known values for T1, V1, and T2 into the equation and solve. So we have V2 is equal to 4 liters times 331 Kelvin divided by 297 Kelvin. The answer is 4.46 liters. And the last step is to evaluate. Does the result make sense? From kinetic theory, the volume should increase with an increase in temperature at constant pressure. This result agrees with the kinetic theory and Charles' law. The volume does increase with the increasing temperature.
So this time we will have very simple activity. I call this next activity as Fast Talk with Boy Abunda. Okay? Fast Talk was popularized by Boy Abunda in his show called Tonight with Boy Abunda. His famous segment called Fast Talk, okay, wherein his invited guests will be interviewed by using fast questions and will be answered by rapid or fast answer. Meaning, mabilisang tanong, mabilisang sagot. It's actually a true or false type of question only. Let's start. The volume of a certain amount of gas held at constant pressure is inversely proportional to absolute temperature.
False, sir.
False. Why false?
Sir, temperature and volume was directly proportional, sir.
Very good, group 1. 5 points for group 1. Second, for group 2. The kinetic energy of gas particles is directly proportional to its absolute temperature.
True, sir.
Okay, the answer is correct. Group 3. When volume increases, temperature decreases.
False, sir.
Okay, false. Why false?
Increases the pressure also increases, sir.
Group 4. The mathematical equation of Charles' law is K is equal to V over T.
False, sir.
Correct? Group 1? True. Group 5. To keep the pressure constant, the volume of the container must increase.
True, sir.
True, very good. Okay? The answer is true. Answer the following. Write the letter that corresponds to your answer. Send it to my messenger after answering the questions. Start. Do this for 10 minutes. Sir Jerry, go say.
Hello, yes, Marlon, are you done?
Yes, sir. Your feedback to my students.
Okay. Tapos na si Edward.
Ikaw na lang daw, sir.
Okay, sige. So, good morning, grade 10 of Bukid National Agricultural and Technical School for their participation. Very participative sila, no? Congratulations for mastering the subject or the lesson. So, based on your PowerPoint presentation, you explained well. Doon sa group 1, group 5, talagang naintindihan nyo yung lesson nyo. And may I congratulate your Sir Marlon for outstandingly explaining your topic. And for the use of your video clips, Marlon, maganda yun, ano? Kasi in your lesson, supposed to be there is a laboratory activity, pero because of pandemic, you find ways and means to show, no? To show the relationship between temperature and volume on constant pressure. So that is through the video clips simulation na pinakita mo sa mga estudyante mo. So congratulations for that. So bale
Thank you, sir.
dito, no, based on your presentation, no, sa video clips, you also develop some of the scientific skills processes of your students, no? Na kung
Yes, sir.
hindi pandemic kung sa face-to-face sa laboratory sana, pero pandemic kasi, so through simulations, na-develop pa rin nila yung mga scientific skills nila, di ba?
Yes, sir.
Okay, so congratulations for that, for a job well done. And then, sa mga estudyante mo, please extend our thanks to your parents for allowing you to participate in this virtual observation and giving you loads. Ano? So, extend our thanks to your parents. Thank you very much. And thank you very much, Marlon and Sir Edward. Thank you very much. Congratulations.
You're welcome, sir. Sir Edward.
Yes, Sir
feedback to my
Marlon.
students.
Your students are intelligent, just like the professor. There's no doubt. So congratulations, my dear students and Sir Marlon.
Thank you, sir.
So overall, congratulations. You have presented or you have delivered your well and
Yes,
thumbs
sir.
up. Congratulations. Thank you.
You're welcome, sir.